hello out there. I knew that when I made the first couple videos about the electronic ignition that I had forgot to show how to do it. So anyway, this here is this. Radio Shack now has these in my Radio Shack, and they're $8.99 before tax. And I also found, hold on, these. I got these today. I got them at Radio Shack. Well, no, actually I got these ones. I got 4 of these, like 2 weeks ago. Some hot chicks waited on me. It was great. And then these, I got 2 of these today. These are the best. These are the 276159. 276159 right there. And if you can see that. But anyway, I got 2 of those. These are great. I love these. But well, like I said, I have this thing here, $8.99. And okay. So anyway, this is kind of like all the stuff that goes to the $5 kit. Now I got to look up some more stuff. And I've got my schematic here that I'm using, and then my diode setup, which did lengthen the amount of time that I could, well, that it would work, because it'll, you know, they burn out. This part here, the chip part right here, that goes in this adapter slot, you can put them right into this board. But you always, if you solder them, and this doesn't work very good, so I will probably go directly into this board with the 556 timer chip. I didn't show it, but I took the base, the solder base off, and I just put the 556 chip in there, and it fit way better. And this is good and solid. You put a piece of tape around this, and it'll never come loose. It's good. Okay, so now I'm starting to round up the other parts I need, and I'll show you some more. I haven't put any of these in the right place yet, but this is your first part, or that's the most important part, and then you just hook it up per this diagram, and it's really easy. But I always have number 1 this way. The one that goes to, this one up here always goes to ground, and this one always has to come around and go to ground. And I have all that in there, and I'll show you what I mean. I'll take it slow. I'm going to try to explain this as fast as I can. I have the schematic in front of me right here. Okay, the schematic is here. Now, I need 10K resistors. Doesn't matter which way the 10K point. Now, what I did, because I was having trouble, I put my positive with diodes, and I have positive to 14, and I have well, 14 to 4. And I need one to, I need one to 10 too, so I need a diode from, okay, I'll get that later. Okay, this is a 10K ohm. It goes from here to here because it's black, brown, and orange. And this one is another 10K one. That's what it says, and black, brown, and orange is 10K. And it goes to number 1. So number 1 is right here, and this one needs to go over to the positive row. 100 ohm or 1K ohm, and that goes from 1 to 2, and 13 to 12. Okay, so those is, I'll just bend these down. Okay, this is the third take of this. I have the chip mounted. I have a black, brown, red resistor, which is a 1K resistor, and a 1K resistor from 13 to 12 here, and then these are, this one, black, brown, red, orange, yeah, that's 10K. Okay, 10K are here, and then it's all there in the schematic. That's what we do that. Now, I have number 6, which is a capacitor. Now, you have to find the side that says negative. because the negative side needs to go to the negative side, or else they're supposed to blow up. I've never seen one blow up. I've seen them blow up, yeah, but not little ones like this. But they're supposed to be able to blow up. I haven't done that yet, or and I've messed around with them a lot. So anyway, the long one is a positive, and the short one is the negative lead. And so we would go 6 to, that's right, 6 to the negative side, right, which is right there. And I'm in. This capacitor, this ain't best. Capacitor shouldn't have long. What I need is a jumper between here and the negative bus. Okay, I need to cut a piece of wire. I have a little piece of solid wire with insulation, real, cheap wire, and I'm gonna strip the ends a bit, that, and make that like that, and I will go from 7 to the negative bus. I'll try it out by plugging it into something, and so first of all I have to make that, and from pins 5 and 9 is out, 9 goes to resistor, 100 ohm. These are black, brown, black for sure. Okay, so that's 100 ohm, and then the gold stripe is just the tolerance. I couldn't get this to register properly what I thought it would do, so I put it in the board, and I'm going to try it where it can be held down, and okay, that seems to be working. Okay, so I'm trying to determine which ones go to negative, and this holds it now pretty good. Oh, actually it lights up there. Okay, so this one is negative, and you probably saw by the schematic that I forgot to put the jumper between 2 and 6, 6 being the second one over from 7, and let's see, 12 to 8. 100 ohm resistor going to this one, and then the negative side goes directly to the negative bus from the negative side of the light emitting diode. So I have to switch these two around, and this one should go here, the first pin, and this one needs to go to the second pin, because when these run, these should flash at the same rate because we have the same values and the same capacitors on each side and that, and it's not a flip-flop. So in a flip-flop I have that circuit too, but this is the flip-flop mode here. You can see one side lights and then the other one lights, and to hook this up to power. What I've got here is I've got a computer power. Hook this up because I only got like 5 volts out of the thing though, but it's enough to run this, I think. And I'm going to show how the emitting diode and everything works on that, so you know when it's working right and how it works. You always got to find the 2 wires you got to put together because they've always got to switch. And now it happened on this one to be green and red, and then that came out of this wiring loom here. What I've got going on here is I'm going to take some of this wire that I have, and this stuff is, it says 22 gauge. I don't know what this is, but I like to put in as big a wire as I can. Anyway, this one's a negative one, this one's a positive one, and right now I'm putting in a new chip. This chip is probably fried because these things cost like $1 each if you buy them in bulk. Experimenting is okay. What I did here was I took this one from the negative bus. These buses are separate. I didn't know. I thought they were both the same. I thought it gave you 2 rows of positive, 2 rows of negative, but instead you have 1 row, well, positive, 1 negative, 1 positive, 1 negative. So there's I hooked this all up and everything, and then I plugged it in, and the lights came on. Now, the lights look like they're just on, but they're not really. They're flashing so bright that you can't tell which flash is a flash. Now, from there, off 5 and 9. 9's actually on this side now, on this side, and 5 is over here because I have the board turned around from my schematic. But off those, you take those directly to the transistor. Now I'm going to show you about the transistor. The transistor you solder, and then I'm going to plug them right into this type board, and I'm going to mount this board in my old style 3-gang plastic outlet box, and with the cover, and I need a bunch of switches. What I'll do is I'll line these up, and I'll do a whole bunch of these so I can switch when one burns out or if it stops working or something. I'm going to show you the different capacity to change the speed in case you want a different speed. Now I'm going to take this one here, which is, wait a minute, no, I want to take this one here. Okay, so this one is between 1 and 2. Yeah, 1 and 2 there. 1 and 2. And I'm going to change that to a mega ohm instead of a 100 ohm. I don't know. One of these. Okay, so if you can tell by this, one of these sides is blinking, or the one LED is blinking, and the other one is at a slower rate, and the other one is firing at a faster rate because I changed this one to a 1 million ohm or 1 mega ohm, and this one here is still the 1K ohm. Show here is what I've done. I've taken a 3-gang box from the Home Depot, and I have drilled holes in here. What I do is I just kind of turn it over, then I outline around the outside, and then I find out, you have to look at the pin placement because one side, this side is actually longer, they're farther up this way. So I just put them on top of my outline, and then with a pencil I go under there and lightly mark where they are, and then I drill 2/4 inch holes in here to fit these terminals, these transistor terminals through. Now you have to take the wire up through there first, up through both these holes, and you want to solder your transistor out here, and then you push everything back, and then pop rivet these down. Now don't forget to put these leads on there because these leads one goes directly to each spark coil, and the spark coil, and that goes to the positive terminal of the spark coil, and the other spark coil would go to the other lead, or the other transistor lead. And what I've done in this case, since I'm only running one coil, is I have covered the other terminal on the other end with a insulated material, and so that it won't short out. Now this wire here from the B terminals, each B terminal, one B terminal will go to one side of the 556 timing circuit. Anyway, I know the one with no stripe is the one that I want to plug in. Now I can plug that into either one. I just plug them in. Just like I had that LED in there, I just plug these in, and I would have both of them working. But I only want one working because I'm only testing I'm going to test a jet pad, and I only need one spark plug for this. Now I use both of them for the double resonator units, and so anyway, I have to show you again. I tried earlier to put diodes in this circuit so that it would be immune from whatever was causing them to burn out. They burn out almost instantly. So we have to go back to having the diode at the positive lead. Now what I have done is I put the in this case I just had to add it because they were burned out almost instantly. Because I've been putting these right after the positive switch. To get any longevity out of the circuit, you've got to have this diode in here. Now the ring or the marked end is going towards the terminal, and the unmarked is going towards the actual positive source. You need a positive lead by itself going to this because this will have the most current. I use so many of these that I buy these by the, I don't know what this is called, some kind of a container, I suppose. And you'll use them up. You can count on it. I want to add this as a precaution. Watch this short clip. What it shows is that this frequency seems to affect electronic equipment. The computer has gone haywire twice since I had it started. What I've got. You saw this old jet pad out of the back there, and I don't think it's full of mud or anything. So what I'm going to do is I'm going to hook this ignition system up to that spark plug, but no one seemed to understand how the jet pad would work. So what I want to do is demonstrate how I thought a jet pad would work. But let's see here, we get a better shot. What I was thinking was that you would stand on it, something like this, and that your jet along the side there would push you ahead, and then you could rock or whatever. But I had thought of it being twice as big with either the jets in the middle or the jets on the outside.